Welcome to everybody, whatever time zone that you're in. It's nice to get a chance to be a part of this organization. One thing I do want to mention in my bio that was earlier on, there was a mention of the ASHRAE GPC guideline on measurement of gaseous buildings. And that's a brand new standard. It's not from 2009, it's from 2019, December of 2019 it was published. And I just mentioned it, I think that would be of interest to quite a few of the people that are in this group. And to Dr. Taylor, it's a little bit of a coincidence with your time in Papua New Guinea. I don't know if you'll notice, there's a picture behind me of the Indonesian half of that island.
Oh, right.
Where I, 45 years ago, spent about a month, which was a wonderful time.
Wow.
Just a little aside, there's actually a drum from the Asmat region, which is right on the border of Papua New Guinea. But onto the presentation here. So this is a very basic presentation. Some of the slides in this presentation, my screen is not advancing.
Put your mouse in the middle and click your mouse when it's in the middle, and then that should advance. And now press your forward arrow, I think.
Okay, there we go. So, you know, some of the slides in this presentation are probably over 15 years old when I was doing some very basic presentations on this, and it's evolved over time. I've borrowed some slides from along the way and tweaked them a little bit for the impact from coronavirus as we see them as a manufacturer of indoor air quality instrumentation. Of course, we have facilities, very diverse facilities from around the world that are asking us for things at different levels in response to COVID-19. And I would say in some cases, maybe not, they're not asking for the right things, or at least in my opinion. But of course, I've been following some of the research and in on a lot of webinars, but I've tried to tailor this to what are we hearing as a manufacturer? So on to the basics here. I'll run through this quickly. Of course, indoor air quality generally refers to the health, comfort, and productivity of more the white collar workers or students or elderly. And the health part of those issues, COVID certainly, as some of the panelists earlier mentioned, it's re-emphasizing the focus on the health part, which often has had short shrift in the 30 years that I've been involved with indoor air quality. Of course, the World Health Organization says that acceptable access to air and water of acceptable quality is a fundamental right. And I think most of this audience is aware that the figure of 90% of time indoors is what most people will spend. So your exposure to air pollutants is much greater inside. Based on a mass intake, that big blue section of the pie, that's from indoor air. Everybody is worried about what they drink, you know, what's in their food. A lot of concern about outdoor air, but to this day, indoor air is off the radar for the majority of people, although that has been changing in recent years, and COVID is likely to change it quite a bit more. So there is legislation in many, if not most Asian countries these days. Of course, there in UAE, you have more recent legislation and more coming in the Middle East and Europe. What's typically regulated? Carbon dioxide, not because it's a pollutant itself, but as a surrogate for ventilation rates, or dilution air coming through instead of recycled air, outdoor air being brought into the facility. Total volatile organic compounds, particulate, carbon monoxide, often formaldehyde, ozone, nitrogen dioxide, and others, sometimes ammonia. nitric oxide, sulfur dioxide, benzene, radon, and others. There are many different voluntary green building certifications, just a few mentioned here. And guess what? They're typically measuring some of the same things because their recommended parameters are most typically based on legislation that has been out in the field. IAQ and energy use are, of course, very interrelated, but, of course, in buildings, we're using 40% in the US of the energy. Most of the people in this audience, I'm sure, are well aware of that, but the average person is almost always surprised. They always expect transportation to be using the most energy. And that 40% is virtually the same in Europe and other industrialized areas. Of that energy use, the top three here account for about 50% of the energy. So cooling the buildings, heating the buildings, and the ventilation equipment to drive that uses half of the energy. And so that has made building energy use a very ripe target. The current emphasis still is very much in favor of that energy savings, reducing greenhouse gas emissions. Well, that's helping to save the planet. That's great. Of course, the real focus is on the energy savings. Of course, ASHRAE's standard 62 on ventilation for acceptable indoor air quality. In 2007, the ventilation rates that were prescribed were significantly reduced, and that's in favor of saving energy. Of course, you have to keep in mind that this is not a health standard. This is based on acceptable indoor air quality based on 80% satisfaction of the occupants. Some of the newer voluntary guidelines have more moved to rebalance that scale, and they're focusing much more on occupant wellness. And again, as some of the panelists mentioned earlier, you can just about bet that this novel coronavirus is going to put a lot more emphasis, because people, as they come back to work in buildings, or those that have no choice, they're in industries where they have to be in the buildings, they're going to be wondering a lot more about their health in the buildings. Many of you have seen this type of cost-benefit analysis, but just to boil it down quickly, I apologize that it's in square feet, not square meters on this slide, but in an effort to save 80 cents per square foot per year by cutting ventilation in half, you can bet cutting ventilation in half is going to cut productivity by 10% or more, and that's going to result in a much, much larger loss in productivity of the employees. And of course, if you bring COVID-19 into the equation, not just the extra absenteeism due to people getting sick, but due to the self-isolation, is going to have a large effect on that cost. So that scale, in fact, I would be very surprised if this doesn't start dropping much more toward the health side of the scale due to the COVID-19 situation. So, dilution is a solution to pollution. Well, not really. Source control is most important. And of course, if you have occupants that are coming into the building shedding viruses, if you're in facilities where you can't have them telecommute, that's a good way to prevent it. But a lot of situations, the occupants need to come there, and a lot of them may be asymptomatic or pre-symptomatic. They don't know that they're shedding viruses, and then you have some that may be irresponsible, and they're showing up even if they are showing symptoms. But you can't always keep the people out that are going to be shedding viruses. So added ventilation, and then also, of course, the control of that ventilation on an ISIAQ webinar that I listened on very recently, they talked about a study in Wuhan where a banquet hall had the diffuser at one end of the banquet hall and the return at the other end of the banquet hall. And apparently people had the virus coming in on the diffuser end, and they followed the air patterns, and the people that were in that air pattern that brought it over to the return side had a large number of, resulted in a large number of cases where people that were more on the edges and corners, the infection rate was much lower. Pollutant pathways, always important in hospitals, but you may have situations now where you have even in a residence, you may want to see, okay, is there a way I can make this room where we know dad's got the coronavirus, is there a way we can make that room negatively pressurized so that it is sucking and not pushing out the virus into other areas of the home. I neglected to mention, of course, differential pressure is important for measuring filter efficiency to make certain that the specified filters are at least achieving specified performance, particularly for the recycled air. And similarly with particulates, while there's many important things for standard indoor air quality in these days of COVID, filter efficiency, particulate meters are not going to measure the virus itself. It's way too small. But making sure that filter is operating at full efficiency makes particulate measurement that much more important. There are a lot of different parameters that are specifically measured that go beyond what are in the typical legislation. And we have seen a very large increase in requests for ozone. And what we're hearing is that people are using ozone generators to help get rid of the virus. I wouldn't recommend that personally, but we are seeing a large increase in requests for ozone measurement, chlorine, chlorine dioxide, and ammonia, because cleaning products are being used.
Sorry to interrupt, you have a minute left. Thank you.
Okay, I'm about there. Little closing on, Grey Wolf. For 21 years, we've been manufacturing equipment for indoor air quality and other applications. Indoor air quality has been our main focus for walkthrough surveys, long-term trend logging with lots of documentation and reporting. And of course, we also have a cloud application where units can be used for continuous monitoring and accessed via pretty much any smart device. So I made it under that minute. I don't know if we have time for questions now, or I know there's a question session at the end.
That's correct. Yes, we'll have a Q&A towards the end, and I'm sure there'll be a lot of questions coming in.
Okay. Well, thank you very much.
Thank you so much, Rick. The next presenter is Paolo Molteni, who's a general manager at Crivan Italia. If Paolo is ready.
Yes, I'm ready. Can you see me?
Yes, we can.
Good. So I shall share my screen.
Yes, please.
Is that okay?
We can't see. Yes, now we can. Mm-hmm.
Okay. So good day, everyone, and thank you for giving the opportunity to present a few things about our company. So as I was introduced, I'm driving the subsidiary in Italy of Crivan Industrial Electronic. It's a multinational German company specialized in sensors and other things, and we support Italian and the Middle East market with our subsidiary. So just a A few things about our company, as it can be a new name to most of the audience. Then we will go through more in detail about the airflow monitoring aims, so which are the sensors that we propose for the indoor air quality systems and ventilation aspiration companies that are working in this environment. So we will also have some product presentation, and then as usual we'll have a certain conclusion. So a few words about Crivan. Our company, in a few words, protect machines, people. Of course, we're talking about the IAQ systems. And as usual, all the companies needs also to be profitable. So we want to protect against air infection, which is it's a common argument since a few weeks, and we try to make things working properly without failure. A few words about the specialization of Crivan, as we are focused on sensors application. So we provide electronic protection, as you see, machine protection sensors, wind and airflow sensors. Here on in the right, you see one of the latest products in this family as airflow sensors. We have also controllers. We provide also products for connectivity and software. So these are our specialization in a few words. Electronics for refrigerant and air conditioning, temperature sensors, and air and weather sensors. In just a few numbers, what we do as Crivan, that is a 50-year and plus old company. We focused in research and development with 16% of our employees there. So we really are aimed to the innovation and new products and new application. As you see, we are the company headquarters is in Fürstenberg, Germany. Different subsidiaries, as you see here in Europe, America, and Asia. As I said, I'm driving the Italian subsidiary since 2012. Innovation in Crivan means patents, and the new patents every year. We also have in-house a special test centrum. This is also open to third parties, dealing with a lot of certifications, testing procedures, just to make this brief. These are the main core, and as I said, air conditioning, ventilation, heating, pumps, energy, and others. So as I said, we also provide with the connectivity, controllers, software, and these different applications for remote controlling, recording, and data logging. Okay, so now more in details about the focus of this webinar. What is a Crivan proposal to help people get a better air quality and the protection against infection and bad quality air? So we propose airflow monitoring sensors. These have specific application in air conditioning and in laboratory equipment. So we can have these sensors installed, constantly installed in the ventilation and aspiration ducts in order to make sure that there is an airflow, a constant airflow coming either in the building or getting from the building outside the building in order to get a good and filtered, secure air inside the buildings. And of course, we have these applications in a lot of kind of buildings, starting from hospitals, which is becoming more and more sensitive to these situations recently, hotels, banks, and wherever can be a group of people living there. Second big family of applications is in the laboratory and in the medical environment. So we are proposing our products for laminar cabinets where people need to be protected from possible infections, as well as clean rooms and other environment or other buildings where people need to be protected, and we need to guarantee the air quality and the airflow in the buildings. Just to get more into details, what we the performance of our products. As an example, this is a ventilation, very simple and basic ventilation ducts. So we can actually monitor the quantity of the air, the inlet coming in or outside the building. We can monitor if the flaps are open or closed in order to get a better control and a secure control. Then we can monitor effectively if the overall system, so with the fans, is working in the proper manner. And of course, we add all of this as a fan control. So we can make sure that the system is correctly in place. As I mentioned, in the medical environment, we also have different applications. So we can make sure that in clean rooms, air is not contaminated, as well as in the laminar flow boxes, we can guarantee people do not get in touch with pollution or infection, as well as in the laboratory control or other kind of medical applications, as you see. This is the overview. Now we have just a small parade of products. This is more in detail, just to give a few specifications of what is needed normally in this kind of market and industry. And this is just an overview of our products that we can offer, that are constantly installed in the ducts. We can also see here a controller with a display. So in order actually to give the operator a chance and all the users a chance to check on live what is the airflow and how the system is working in place. This is our new products. I want to point out just a few things. Very easy in installation in the ducts. We have also a couple of LEDs indicating the status of the product. So very easy installation and easy checking of the flows in the ducts. This can be also installed in a different position of the ducts. It doesn't matter about the airflow direction, so it can easily react and measure it. A few specifications. What we see is normally needed in the market. The measuring principle for our sensor is calorimetric. I will spend a few words on this principle in a few slides. The monitor range is from 0.2 to 10 meter per second. This is normally covering the range that is used in ventilation and all the air treatment applications. We see the different ambient temperature, and we have different output configurations. So actually, as I said, it's easy for the installer to get this on place. Just a few words on how to install our sensor.
Paulo, sorry to interrupt. You have a minute left.
How many?
Yeah, 1 minute left.
1 minute. Okay, good. So this is just to mention how our sensors can be installed in the correct and the wrong way, not in the band, but definitely in the pipes in the middle of the pipes or the ducts. Calorimetric measurement means that there is an internal resistance, and then we see according to the measurement of a second resistance here, if it's heated and how much, and so it's possible then to measure the airflow heating our sensor. Okay, just to show you, we have different families of this with a different output signal. As I mentioned, the controller with a nice display, so you can really see what is the airflow measurement there. And as a conclusion, I hope I could briefly explain you what is the proposal of Crivane for the IAQ needs. And we have different tailor products, as I said, very flexible for different needs. And in case you need to get in touch with us, you have our directions there. So thank you for your attention.
Thank you so much, Paulo. That was Paulo Molteni from Crivane. The next presentation, the last presentation, and after that we go into the Q&A. The next presentation is by Tolga Kandin, who's the head of strategic business development and retrofit at SenseGreen. SenseGreen. Tolga, you're on.
Yes, everybody. I'm freezing in my office right now because I pumped up the AC because I feel like I cannot breathe. But it's not helping. I think there is something wrong with the fresh air handling unit in my office. Are you able to see my screen, everyone?
Yes, we are.
Perfect. I feel like a teenage YouTuber now, so I feel like saying, hi guys, welcome to my channel. Please hit the like button and subscribe to my channel. But yeah, this is the post-COVID. We are all online now. I'm glad that there is an amazing audience with a lot of familiar names that I know some of them, which some of them might know me also. Dr. Stephanie, we've became your fans today. Many thanks for the great management. And then I see Iyad Ismail and Dr. Leo. It's been a long time. Nice to see you as well. I see Hakan Bey, Halil Bey, Murat Bey, and Zakaria and Hannah and Rohit Salunke. And definitely Frederick, who graciously granted me the best spot, the last spot. So I would like to salute you all for this great knowledge sharing session. I took 2 notes, consistently repeated. How do we ensure accountability? How do we ensure the operations are operating correctly? How can we enable accountability? So I have a solution. We have a solution, and I hope that you'll be as excited as me. I present this solution to you as well. As it was nicely presented earlier, we are paying a lot of attention to the water, even though we don't drink tap water, even though it is probably very clean, we still want properly regulated and quality controlled water, despite the expense of adding to the plastic mountains. So it is time that we invest into the quality of the air that we are breathing in. Every year, air pollution is accounted for 7 million deaths. Yes, 7 million. And we, as spending our majority of our time indoors, air is the slow killer, which much worse impact on the children and the elderly. They say that 50% of the illnesses are caused by the poor indoor air quality. And I've been last 13 years in this part of the world, in the sandpit in UAE most of the time. And our region is not very lucky in terms of dust, sand, and other parameters. And the inflated energy costs due to the extensive AC usage, which unfortunately is controlled by single parameter, temperature. As you professionals know very well, air is like a soup with many more ingredients than the Italian minestrone or my favorite harira soup of Morocco. And can you imagine cooking those soups only by single parameter, temperature? So definitely not. Here comes Sense Green. We started with the vision to solve the air. What? Wait, is there a problem with the air? I think there is a problem with the air. That's why we 70, 90, 100 people all gathered up our screen discussing how we can solve the air. We started as a IoT company with artificial intelligence added, multiplied over HVAC. That is what Sense Green is. So I always say in my past half decade of experience in optimization, where I was focusing on the energy optimization, I always used to say that the engineers are going to save the world. I mean, not the politicians, not the others, if not we destroy it. So engineers are going to solve the major problems as they have so far done. And I also always say that human efficiency over everything. If we can lift up the human efficiency by 1%, 2%, we can make this world a much better place with our collaborative output, I can say. So we started as a software company. We thought that we will be collecting data, and then these data will be used to optimize the spaces. Then we realized that there is no data, or there is wrong data, which is even worse. So we started looking at the sensors in the market that is measuring the air parameters. We found them either way too expensive or not effective. So we ended up building our dream team sensor, which we call Sense Nodes. Together with the Sense Node, Sense App, and Sense Cloud, we are able to offer stage-by-stage solutions. Number one, measure it. Number two, fix it. And then stage number three, integrate and automate it to solve the air problem, to make self-running efficient buildings. We are able to utilize the existing BMS systems to operate them more efficiently. Or if it's a small branch of a bank, let's say, we can still integrate with the fresh air handling units or the chiller or the FCUs. We are able to do all of those, because they are only now driven as per one parameter, which is the temperature. So are we the first one to do it? No, we are not, but we are the best one technically and economically, a total package, and they're very affordable for mass installation. Not next year. You can start doing this tomorrow to see whether your buildings are properly managed, operated, how is the air quality, and if it is good enough, you can showcase it to your clients, customers, consumers, tenants. But if it is not so good enough, then you can take actions. Where shall I change the filter? Where shall I inject more oxygen? So we have this concept of we are vendor agnostic. We can integrate with BMS or we can work without the BMS. We are cable free, zero installation costs. Even my 7-year-old daughter can plug it and play it. One gateway is enough to monitor, communicate hundreds of sensors. It's suitable even for greenhouses, farms. And with the AI-based engine modeling,
So sorry to disrupt, Tolga, you have a minute left.
Perfectly fine, because I have also a minute left. With the AI-based predictive modeling, we are able to foresee what's going to happen in terms of occupancy, in terms of seasonality, and instead of cornered reactive systems, we are able to make smooth transitions in the HVAC system. So here's a case reference which we installed in an office building to see, and you can see before there were so many overcooling, and after the integration, we were able to make it smooth and without spikes and ups and downs air conditioning that saved energy also, but mostly that increased the maintenance lifetime of the asset, and also it helped people to increase their comfort level. So I see a future where all people will be looking at the air quality ratings, like when you are looking at choosing which app to download. People will look at the air quality ratings before choosing their banks, choosing where to shop, which school to enlist, and even which apartment to rent. People post-COVID will pay the utmost attention to see. So in this very inauguration, in this company called SenseGreen, headquartered in Singapore with offices in Ankara, Abu Dhabi, and Dubai, I invite you all to connect with me, to communicate with me, and put your heads on. Let's build this legacy together with you towards health, energy, and well-being. Thank you very much. Let's solve the air together.
Thank you so much, Tolga. And with that, we go into the Q&A session. We don't have many minutes left, but we shall try to get as many questions as possible inside. A big thank you to all the panelists and the presenters for staying back for so long to take questions now. Stephanie, would you like to lead by asking any question, or would you want me to pose a question?
How about if you put the questions out there? I think you have more accurate pronunciation of names.
Okay, I'm going to try. There's one question that's come for, I'm just, to be patient with me, I'm just scrolling up and down. Yes, this is a question from Amin Habash, and this question is to Dr. Iyad Alatar and also to Dr. Stephanie Taylor. How can engineers measure or quantify the cleanliness of any space from pathogens? Is there any standard or code to verify pathogens count indoors? Stephanie, would you like to take that first, and then Iyad could follow that up?
Sure. So I think I tried to answer some of these privately or on the platform, but so I am not aware of any indoor air standards that incorporate microbial testing results. I may be unaware of some, in which case you can tell me, but there are some very accurate tests now available using these new techniques, metagenomic analysis, for specifically COVID-19 or less specifically for viruses and bacteria, both in the air and on surfaces. The tests tend to be somewhat expensive, like $100 to $200 in US money. As the competitors enter the market, they're getting less expensive. But so yes, tests do exist. And I don't know of standards that incorporate the results into their guidelines.
Iyad, thank you, Stephanie. Yeah. Iyad, would you like to?
Yeah, I just want to comment from a particle or PM point of view and gaseous contaminants. There is, I believe, a wide spectrum of products that can do that. But I also want to highlight that most of the focus, whether it's by standards or the filtration acquisition or selection, is based on particulate matter, on particles. We need to bring on board the gaseous contaminants, which will automatically bring in sorbent or chemical filtration to be part of the equation. This will necessitate a couple of things. One, you would need to have a physical and chemical characterization of the urban air. Therefore, based on that, it will influence your air filtration selection in terms of fresh, pre, fine, and possibly absolute filtration. Without this aerosol monitoring tool or air quality tool, I think we're just making an over-the-counter solution that fits all the building, and that doesn't work.
Thank you so much. Yes, Simon.
Hi, thanks. I popped an answer on this as well because it's something that speaks to my heart and experience as a microbiologist. And there are some standards obviously in some areas where you will need air quality standards when it comes to microbes. And we're thinking about healthcare and thinking about some manufacturing. And I used to work in a microbiology lab myself where we would do daily monitoring for airborne contaminants. But one of the issues that we really face is that, it's easy enough to detect pathogens or detect microbes, let's say, in the air, but to determine whether they're going to be pathogenic is another story. And I had a manager who explained it quite easily in simple terms, is that particularly from the genetic perspective, it's very cheap and easy and quick for us to genetically classify what pathogens or what microbes, are in the air. But to find out whether or not bad is a much harder question. And he said, he gave the example of his name. If you Google his name, then you'll find a result that says that it's him. And also you might find a result that says that someone with the same name is a violent criminal. And so that's kind of what it's like where we're at the moment with sequencing and looking at metagenomics. We can find out whether something is there, but to find out whether that's a good version or a bad version of the same pathogen is difficult. In the same way with coronaviruses or any type of viruses, some of them will be highly pathogenic and cause pandemics, and some of them will be completely innate. So for sure, to answer the question, there is standards there, but we don't apply them regularly to most public areas. And we don't expect most public areas to be sterile anyway. We expect them to have airborne microbes, airborne viruses, airborne fungi. Whether they become pathogenic is going to be a much harder question to answer.
But I thought the metabolomics analysis was beginning to reveal whether or not there's antibiotic resistance and what other sort of virulence factors exist.
Yeah, the more data we generate, then the more we understand it. I think this is how it goes. But I think what's commonly found is that if you go into an office building, let's say, and you do air sampling and you do metagenomics and metabolomics even of one room, and then go to the next room, you'll get a completely different result. And then,
I didn't realize you were a microbiologist, Simon. That's cool.
Yeah, this is the background. So it makes things very difficult. As a microbiologist, we have to rely on typically, I think we have to go that step further from doing sequencing and doing detection this way and understand deeper what we've found, and this is what takes time and what becomes expensive as well. But I think the more data we generate, the better.
Don't forget, everybody, that a diverse microbial community indoors and on our bodies and in our bodies is associated with health. It's just that we don't want to select for the pathogenic species.
I think I gave the example in the response as well of what we learned about over disinfecting like our homes and our areas. It's like from an advertising perspective, it's very common to see that, okay, you want to clean everything, all your clothes, all your dishes, all your surfaces with things that are 99.9% disinfectant, but at the end of the day, we've learned that this is not necessarily good for your health. Yeah. And that owning a dog and running around in the dirt every now and then is what makes us human, and we should continue to do that.
That's why I have 7 dogs.
Perfect.
Right. Thank you so much. There's a question that's the questioner has chosen to be anonymous. And the question itself perhaps could have been drafted slightly better. I'm just trying to make sense of it. It says, if consultants and contractors follow required standard for during the design and commissioning, after the few months commissioned value not achieved, I think and I think Simon, you answered this question. I really like you and also Dominic to perhaps answer this. I think the gist of this question really is, it's one thing to establish standards, but then it's quite another to enforce them. Or maybe I'm reading it wrong. Would you like to sort of clarify this question and then perhaps answer if you understood it? Because I saw you answered that.
Okay. Can I jump in also in that one, Surrender?
Sure.
Because
First, if
Sure.
I may ask Simon to answer first, and then
Yeah.
I'll come back to you, Tolga, and then Dominic.
I think that, just to be quick, the answer that I put in is that it becomes very difficult to understand when who is to blame, especially after the process of commissioning or after the building occupation has occurred. And there's a facilities management company. There's there's an occupant that may be causing the issues. So to really pinpoint who is to blame for, let's say, indoor air quality becomes extremely complex, and the amount of time spent from a regulatory perspective or from and even a legal perspective is really a tough nut to crack, I think, in this case. And so my let's say suggestion in the comment is that it becomes the building owner or the occupant's, let's say, responsibility to make sure that they get what they paid for effectively, and to hold someone accountable rather than to have a overwhelming regulatory mechanism or monitoring system to be able to look after this. Be interested to hear what other people have to say.
Thank you.
Excuse me, I have to, I apologize, but I have another webinar that begins in 1 minute, so I should step off. But I just want to say thank you very much. And I've really enjoyed this discussion, and I look forward to seeing the recording.
Thank you so much, Stephanie. We appreciate your time and your expertise.
Thank you very much. I hope to hear from you. You have my email.
For sure. It'll be a pleasure. Bye for now. Tolga, yes, you wanted to answer that question.
Yes, indeed, because my job has been retrofit, and I've been doing retrofit in probably over the past 5 years. I've inspected more than 300 buildings in Dubai, Abu Dhabi, Sharjah, Elaine, Saudi Arabia, and Qatar. I've been to the best buildings and the worst buildings, including airports, the best engineering, the Mercedes of the equipment. And what I've seen is actually, it's a disaster. And even the facility management companies, they don't know that it is a disaster because they don't want to know it. They already have so much headache, day-to-day issues that they need to deal with. Even though they are driving the Mercedes, it is going in an awful situation from both an energy perspective, and air, unfortunately, is not even in the agenda. So I believe there has to be a regulation pushed, unfortunately, by the government to say that I want to see, I want you to record your air quality in the schools, in the hospitals, and I will be checking that. It's like the Legionella. For example, the facility management companies, they have to, on a periodically, check the water quality through the third-party laboratories. But when it comes to air, they are checking the air quality on a quarterly basis. And imagine the air is changing ups and down during the day, so quarterly inspection is nothing. So I can see that in the upcoming legislations, there will be enforcement to record, monitor the air quality real time and accessible by the municipalities. There is no other way around it.
Thank you. Our Dominic McPaulin, our regulator from Bahrain. Yes.
You might regret asking me this question or me answering this question. I feel very personally, very strongly about this. I think the whole industry, we used to have architects who were in charge of buildings from start to finish. We used to have engineers who were in charge from start to finish. We have had this rise of this new player in this region, which has taken over, and that is the project management professional. And honestly, it has been a degrading of architecture and a degrading of engineers, and those professions have allowed this to happen. where they're sitting outside the door while the project manager is carrying the relationship with the client. And I used to have a sign on my wall. It used to say one thing: shoot the messenger, because these messengers are really project management has been diluted. The professionalism and the carry through from expertise in the engineering profession and the architectural profession has been seriously eroded by this new layer between client and professional. And the game is up. We have to stop this. We have to get architects back into their roles and engineers back into their traditional roles, whether it's under FIDIC or whatever contract direct responsibility and accountability. And I think that's the main problem that is causing this difficulty in quality. Thank you.
Thank you. I'd like to bring our consultants into the discussion. Would you like to comment on it? Zakaria, Prabhakar Nayak.
I will. It is not project management. Project management is there during construction. When the project is handed over to client, that is the end of their role. Later on, it comes as a facility management. That is where you are lacking. And I blame this for DM because, as somebody said, quarterly, Tolga said, I believe, every quarter you must go and visit a hotel, a hospital, and a school. Then put penalty. Even you start with 10,000 dirham per visit, doesn't matter. Close the school if they don't meet the standards. I keep repeating this. The DM is responsible for controlling the quality after handover.
And not only quarterly, make it a real thing. Why quarterly? It's ups and downs.
Yeah, you are right. I agree with you 100% because one of the schools where I audited 2 years back, it is in very bad shape. It is worse than COVID. The humidity RH is more than 80%, and the KG1, KG2 students cannot talk. They will get pneumonia. They will get lung infection. Who is to be blamed? The FM. You know what they do? They switch off the air conditioning after 3 o'clock to save money. Next day morning, they switch on. So fungus is there already. I am telling you, the DM must make a regulation to inspect regularly, like how they inspect hotel for foodstuff checking, and put penalty for those people because they are all businessmen running the schools. Yeah, they want money. And I'm telling you, this has to be imposed. You must, in fact, I'm going to write to DM on Kent College because I was involved as a consultant during design, post-contract, post-mortem, and now FM is very, very bad. They switch off the AC after 3 o'clock. Thank you.
Thank you. Mohammed Zakaria, would you like to comment? And then I would like to come to Anbalagan after that.
I would like to add a small point in addition to what has all been discussed here. There has to be enforcement of the regulations, but then enforcement has to be done by certified, qualified personnel. If you don't have properly qualified, certified personnel in charge of enforcement, you are back to square one. You don't enforce anything. So various certifications like healthcare facility design professional certification or various other certifications that is available should be considered as some kind of minimum qualification for enforcement personnel. And many times the budget constraints come in the way to compromise on the quality of the personnel, and which in turn has a domino effect in terms of enforcement.
Anbu and then Barry after that, please.
Yeah. Yes, I think most of the buildings, which is you talk during the building permit stage, which the authorities have a control on the consultants, and they are emphasizing the requirements of the compliance with the codes and standards, green buildings and everything. But then it drops out at that point of time. During the handing over stages, there is no involvement, there is no codes and standards which dictate. Except on green buildings, there is a bit of a checking which happens from the authorities. The rest of it is completely it is left to the contractors and the the consultants on board. And Dominic hit the nail. The PMP comes in between because their aim is to finish the project on time and hand over to the client as it is, whichever condition it is in, because the effective use starts. So there is, at that point itself, there is a problem, which starts. Then subsequently, during the handing over, FM, in some of the projects which we are involved in, they come in during probably 6 months, if it's an 18 months project. So they come in around at least 4 to 5 months in advance, and they start looking at all the angles, in terms of the maintenance, in terms of the access to the equipment, everything. So if it is done during that stage, and that means that the client is serious in running the building subsequently. In such buildings, we have seen that they are done very well. The building BMS is done properly, commissioned properly, handed over properly, and it continues. So these are good buildings, but majority of the buildings, if you see, there is, the owners, in the way the real estate market here, the developers, they just want to hand over and run away because they don't take it seriously. None of the concepts which we think during the early stages, it's all just thrown to the wind, and people just run away. So there is this FM that has to have a serious look at it, and that is an area Dubai needs plenty of focus, I would say, which includes IEQ. IEQ, absolutely, there is no follow-up, subsequent to the initial designs. That's it.
Thank you. Barry, would you like to comment?
Yeah, sure. A good project manager is worth his weight in gold because the building would be finished on time and it would work from the start. And if you look around, there are very few buildings where that happens. And I agree with Dominic, what he said. When the architect used to manage it, it used to be a lot easier. And part of that reason, in my mind, is because there were less people in the chain. And instructions went straight to where they were meant to go. And everybody understood what their responsibilities were. In terms of buildings not operating after being handed over, BISRA in the UK implemented a system called soft landings, which you may have heard of, which I think is about 15 years old now. And what they did was they went through a number of high-profile buildings, and interestingly, they picked high-profile, very sustainably designed buildings as exercise to see if they were meeting the targets they were designed to build. Without fail, everyone failed. They weren't achieving the results. There was one classic building, which if you get the original soft landings report, there were something like 82 controllers in the building. And a year after handover, nobody knew what they were doing. The designers came in, couldn't explain them. The contractor couldn't explain them. And the FM company couldn't explain them. So there's all this equipment in a building that had been paid for, it cost a lot of money. Nobody knew what it did. And it's really sad that the industry has got to that stage, but it is. And what's happened is, as I mentioned earlier, it's not getting better, it's getting worse. And to do that, to improve things, first of all, we have to go back to basics. We have to go back to the very basics of what we're trying to achieve. How can we achieve it and keep it simple? Because if we don't do that, 50 years' time from now, we'll be in the same position we are now. We've had all these pandemics, as we mentioned, and I've been through a lot of them. Our buildings are not, have not improved to address it in any way whatsoever. And the worry is that in 6 months' time, 12 months' time, when things are back to normal, people will say, well, yeah, we don't really need to do anything because it's not going to happen again for another 20, 30 years, and it will happen, and it will be worse.
Great point. Great point. Thank you, Barry. This is a question perhaps to the presenters. This is coming from Sudeep Balasubramaniam, and he's asking, what are the measures taken to ensure that the quality of data obtained from IAQ sensors is accurate, or the quality is good? Do you use an accredited lab for this measurement? Do you think it is ideal to do so? I would like the presenters to perhaps answer this question. Maybe Leo, Paulo Molteni or Tolga, you can sort of extrapolate it in terms of the technologies that you presented today, if you wish to.
Thanks for the question. Can you hear me?
Yes, we can. Thank you.
Okay. Indeed, it's very important to use high quality sensors and to keep them calibrated according to ASHRAE standards and procedures. So we normally calibrate them every 18 months. It's very important. You don't want to fly blind. You want to know where you're standing and if the values are true, because if you measure something but it's not the true picture, what's the point? So it's important to install it properly and maintain it properly.
Yeah, let me also do my explanation. Our sensors are pre-calibrated from the production, and then it is tested and verified by a third party. And inside the sensors, by the way, these are the sensitivity of it. And inside there is a special chip that is using a technique called ABB, based on artificial intelligence. It is able to recalibrate itself in case of it is facing. So we are very keen on the data, because once we looked at the existing data in the market, I mentioned in the beginning of my pitch, there was either no data, or which is worse, there was wrong data.
Mm-hmm.
So it's imperative for you to have the right data. That's why our sensor is quite in the top scores from a sensitivity perspective.
Thank you. Paulo, would you like to answer that from your product's perspective? You're on mute. You need to unmute yourself. Yes.
Okay. Yes, absolutely, yes. All sensors are calibrated in production, so we have 100% of calibration in production. And this is done when the product is designed and every some numbers of sensors. We repeat the testing in two special laboratories. One is an independent, fully independent laboratory in Germany. The second one is what I presented, is the Krivan Test Centrum, which is also an independent lab, but of course it's included in the Krivan holding. So it's better to be fully transparent on this. So we made the test calibration of our production several times during the year with these two partners, and then in production itself, Krivan calibrate the sensors 100%.
Thank you. And I think that's all the time we have, really. We have overshot the time limit. First of all, I appreciate the fact that all of you stayed back for this late to participate in this Q&A towards the end of the presentations. Thank you so much. Our apologies for running beyond the scheduled time, but I hope you agree with me that this particular third edition of the IAQ webinar series has been useful for me from an editorial point of view. It's been great. I've got a lot of fodder for the next issue of the magazine, so that's great. And what I mean is that we are going to be reporting and carrying all the information that we have gathered here, myself and my colleagues in the editorial department. I just have one comment left, and this has come from Amin Habash, and he said, maybe one of the strongest statements made today was from Dr. Taylor, that engineers need to learn medicine. I'm an HVAC engineer, and I totally agree with this statement. So I thought that was a great statement to come, and it's sincere appreciation to Dr. Stephanie Taylor, who sadly had to leave. And we shall be taking this message across to her. I'm sure she'll be delighted. But thank you again. Thank you so much for so willingly giving your time and sharing your insights. We do appreciate it. On behalf of CPI industry, thank you, all of you. Bye for now.
Thank you.